And we're again very good on time, but I see you're already here, so I'm happy to start. You can just talk more slowly or talk about more stuff, because now you have 5 extra minutes. So let me just quickly introduce you. You're Sebastian Baumann from DATAbility, and you'll be talking about intelligent decision support, enabling CSM and FSM with health monitoring for spare and service handling. You studied mechanical and process engineering with an emphasis on turbo machinery and aerospace. And within your doctorate, you were focusing on data analysis of flight data recordings and flight operational data. So you now have 20 to 25 minutes for your talk. And again, if you leave 5 minutes at the end, we'll have time for questions, but feel free to use all the time you have. Thanks for joining us.
Thank you. Thank you for the introduction. Thank you for having me. I have to disappoint you first. I want to talk about something else. It's not customer service support and field service management. I brought a use case with me from one of our customers, and you learn how we work with our customers for a decision support system in production and manufacturing for production planning. So I think it will be a very, very interesting use case for you. So don't be disappointed if you want to talk with me about customer service management, field service management, predictive maintenance, then come back to me later. So you can see on the slide, we're talking about mechanical engineering and machines, and I will talk about our customer in a few seconds. So what we are in general doing as DATAbility is we want to tackle downtime and inefficiencies of our customers. So our customers have to make a few decisions, a lot of decisions in a workday under uncertainties. The workflows are often manual. Every person has to make decisions by their own or maybe ask colleagues. But not every colleague is trained to answer the questions, because our real world is very complex, products are very complex, and we're talking about our customer which produces products in a batch size of 1. So every product of our customer is individual. They look quite the same or very similar, but it depends on which application they run the product, so every product is very, very varying. So your lack of clear system insights, your lack of an interpretation, an automated interpretation of your data you already gained, and your lack of recommendations, assisting in your everyday life decision-making process. And this is what we do. I brought with me our solution 8Now, which helps you in predictive maintenance, for example. So with 8Now, we automate the interpretation of complex machine and process data. And what we're doing is quite every time the same. We do performance analytics. We monitor KPIs. We monitor thresholds. So that is very common, right? We do condition monitoring with it to diagnose anomalies, the root cause of anomalies, and maybe, or not maybe, to say the anomaly is coming from a distinct failure of the system, and the failure is XYZ. That does our solution 8Now. And we do with that, on top of this, we can make predictions, how long a part will last in a certain use case or in operation. So monitoring KPIs, anomaly detection, diagnosing failures and states, and predict future states. This is what we do with 8Now and what we do in every project and in every solution we develop for our customers. So keep that in mind. We are a very small team. We have 6 employees. I'm one of the founders and managing director. Our background is in engineering, and we develop and delivering decision support systems for our customers since 4 years. We founded out of university. We made our promotion PhD times at TU Darmstadt, and then founded the company. As you can see, despite we are 4 years on the market, we have a broad and namely customer base, ranging from our biggest customer, Deutsche Bahn, since over 2 years, over mechanical and engineering companies, to automotive manufacturers and suppliers, even energy providers, and even telecommunication providers like Vodafone. We had use cases with them on predictive maintenance. And our USP is to build up so-called hybrid models. So in engineering, you will know if you work with data from the real world, from production or from sensors from vehicles in reality, only with data and AI, it will go wrong. A solution for this, an automation solution. So we build up hybrid models. What we do is we're combining the conventional world with engineering methods, physical models, mathematics, statistics, with a more high sophisticated world, the machine learning AI world. We call it hybrid models, and it could be also a rule set combined with an AI model. And we do this in every project. So yes, it's hard to scale automation solutions out of it, but you get a robust and reliable and transparent model for our customer. And this you can deploy then on different sides of our customers, but in a very, very sharp use case or in scenarios. And I want to talk of one of our customers. And it goes about, or the use case is about injection molding machines. So every day we have a lot of products made from injection molding, like the chip here from the cloakroom you get in the entrance. It's produced by injection molding. So this is one of the machines in the middle. And the two most interesting parts are the mold itself. It gives the geometry of the product, of the plastic product in mass production, and you need a system to bring the melt into the mold. And our customer, EWIKON, is such a customer which produces hot runner systems that brings the melt into the mold for such machines. And you can see the different products you can produce with it. And here you can see with one shot of the machine, you are able to produce 100 of parts in just a second. You see it here in the video. And now I can talk about the hot runner system itself. You see here a wide range of hot runner systems from small to big. And with that, you are able to transport the hot melt into the mold. And so EWIKON is an equipment manufacturer for injection molding machines. And if you want to manufacture plastic products, you need an injection machine, you need a hot runner system, and you need the mold. And every product you want to produce has its own hot runner system and its own mold. So we're talking about batch size production of one. EWIKON is located in Hessen, right as we do. We are based in Darmstadt. It's in the south of Frankfurt, and EWIKON is between Frankfurt and Kassel in Hessen. It's a typical example for German Mittelstand company. So with over 40 years of experience in the hot runner system building, manufacturing, and it produces the hot runner systems with a high quality for high quantity products, and they want to reduce the sprue waste, so don't let hot melt go into not go into the form, the mold, so that you can produce very, very efficient. So I talked about batch size of one, but the products are very similar, especially the production steps. So it starts on the left with an aluminum plate, which is gun-hole drilled. Gun-hole because over the whole length and the width, the plate is drilled. So it has to be a high precision drilling, and afterwards it will be milled. And with that two process steps, it's all about the machines are NC machines, so you get automated process times out of the machine you can work with. And they drill and mill the tunnels for the melt and also cooling holes into the plate to produce such system you saw on the slide before. Here you see also such a system with the cooling holes and the melting holes. Maybe there are pins on it, and here you can see you can produce in one shot over 90 products at a time in such an injection molding machine. And the challenge for our customer was to estimate the lead time, so the manufacturing time from I get the plate, I drill, I mill, I have to set up and handle the part, I have to set up the machines, till delivery to the customer. So the lead time consists of different shares. from shares from the NC machines. It's from automation. I get a clear time in seconds. How long will it last to do gunhole drilling and milling? But I do not have timestamps for handling, for setup times. If a product is very high complex or arises with high complexity, you have to rearrange the plate in the machine. And I do not see this in the data they already gained. So different shares over the whole value chain of the manufacturing processes. Here you can see more detail into the part with the cooling holes and the melting holes. And this is done by those two production steps. So the status quo is currently the lead times are estimated by hand by humans in sales and with system experts using CAD models and drawings. So they open up 3 documents and have to fetch the complexity of the product for the customer to estimate how long will it last to produce the part. Not on the machines, not the NC time. The whole lead time from the plate was delivered to I took it to the machines and I can pack it for my customer and send it out. So it has a high company relevance to estimate those lead time because you want to plan your production and you have to estimate how much effort I have to put into this product. So it has something to do with sales because when my lead time is way over my estimation, I lose money. And it has a high customer relevance because you want to say to the customer a specific delivery date where you can expect the part he ordered. So we built up a system, a model, an AI-based model with relevant characteristics out of the data our customer had. And you see on the bottom, or here you can also see our hybrid modeling. On the bottom you see data from systems like ERP systems, the CAD, the CAM, where you get the NC machine times, where you get more information about the customer itself, and the products from drawings and the CAD models, so the computer-aided design models where the product was designed for the customer. And the customer said, check mark, this is the product I want to, the hot runner system, please produce it. Then we talked about a lot with the domain experts of our customer. That's the middle layer, the expert knowledge, because the machine operators, they know their products and machine the best and the characteristics to handle and set up machines and processes for every product. And on top of this, we can talk about models in mathematics or using AI for regression and classification. And keep in mind, we try to only work with the bottom layer, the data part from our customer, stacking up this with AI, but we could only explain about 40% at max of the whole variance of the lead times. So only with data and AI, it won't work. We have to cover over 60–70% of the variances in explainability by bringing in the models into expert knowledge and regression and classification models. So we developed a solution, you see here on the right, and our customer is now able to use the application. In the sales process with the end customer of the hot runner system, we use the data out of this, and we had to change a little bit the process steps in the value chain. So we work also with the CAD and CAM models, but to do this, our customer has to set up his IT a little bit different to the state before our system worked. And the workflow, so we changed a bit the workflow, how the expert work in the sales process and creating those information. But now our customer is able to estimate fully automatically the different shares of the lead time for a whole bunch of their products. So I said about there are various types of the product. Everyone looks very looks the same, but is very, very different in how to manufacture a product. The application contains now transparency also for the sales and domain experts at our customer, because we are able to, in the bottom right of the application, we can say, the part you've given me, or the order, it takes about here 35 minutes to manufacture, and you have a setup time for the machines of about 12 minutes. So the lead time has to be, in addition, 47 minutes. And we compare it to historical orders our customer had, EWIKON had, and say this part is very similar from the data with part XYZ, 1, 2, 3. You see it here on the right. These are top 10 parts that are quite similar to our part. So the sales experts are now able to have distinct incidents or characteristics given at hand, to look up older cases and see what the part took in time, took in lead time, took in setup time, and as well as can compare it to the current order and rearrange things, or get more transparency for the decision of what is the actual estimation for the lead time. So it helps to prep your production a bit more, or way more. You get historical performance analytics of your orders, and we help our sales and also customer service for improvements with that. So the process manually took about 15 to 30 minutes. If you have a company that has over thousands of orders a year, you can spend or reduce the effort for estimating the time quite a lot. So this solution, it was a PoC. We took it into MVP. Now we maintain it, make it even bigger for the customer, get the return of investment or the return on digitization in under a year. As we heard before, how much can a PoC cost? So I think it was a very, very valuable PoC, and we are a lot better of the manual estimation, as you quite know, up to 60% before. Now the whole process is automated, so that's the big benefit for our customer, and then the estimation is 60% better than before. So what we learned are 3 things, or 3 pillars. You have to create a great database to do such a PoC or an MVP, or deliver a decision support system. So our work itself was only 2 to 3 months, but over a period of time of about over 2 years. Why is that? We spent only 2 months in building the application and run it now at our customer. But our customer has to set up processes new. How the data generation is, for example. We started with a process analysis and recognized in construction, every person in construction constructs a little bit different, and some standard features in the CAD system are not used by everyone. So we have uncertainties in the data, and we couldn't work with the data because we couldn't clean it, and because the data generation was wrong, and such characteristics we had to clean up to build up the system. And also I talked about the process steps and sales and creating the CAD models we had to tackle. And I think it was a huge benefit for collaboration of the employees at our customer. So they do cooperation. But with our project, it was a really, really big digitization project. They learn a lot more about the work from colleagues. How do they work? How they work with the data gained from me, gained from them. So it was a huge success, and we all were in the same boat and took the digitization program over 2 years together with a great success for this solution. So thank you very much, and I hope you enjoyed the talk. Talk to me about predictive maintenance, but also about decision support systems in production. Thank you.